Welcome. In this video we will learn about multiple color object detection and tracking. Here I am using color combination. For this I will keep on tracking multiple objects and will also find out the color of object here. So first let's see the output. Let's run my script. So this is a script. Let's open multiple color object detection and tracking.py. So this is a script. To execute it, I should go to run and run the module. It's running. You can see webcam is on. It's detecting my face as orange. I will take a box here, red color box, it's showing red. Here I got another box which is blue, and here I have a ball, table tennis ball, which is showing orange, and it is detecting my t-shirt also. So in this way it will track easily whatever object you take and display it in front of the camera. So this is how object and color tracking is done. Now let's see the code behind it. First we have to import the necessary packages. From collection import dequeue. This module implements specialized container data types, providing alternative to Python's general purpose built-in containers, dictionary, list, set, and tuple. And next import numpy as np, which you know. Next import argparse, this also we know. Import mutils, a series of convenience functions to make basic image processing functions such as translation, rotation, and resizing. And import cv2, Python strong library for dealing with images and videos for object tracking. And finally import urllib, this module for reading image from URL. So next, construct the argument parse and parse the argument. The whole paragraph, that is ep is equal to argparse.argument parse. The argument is video or a video file. You can mention the path of the video file, which is optional. Here I am using webcam of my laptop, so we'll leave it optional. Add argument, buffer, help, max buffer size. So basically we are taking the input from the camera itself only, which we'll see later on. Now define the lower and upper boundaries of the color in HSV color space. So upper and lower, red, green, blue, yellow, orange. So these are the values. Now let's define standard color for circle around the object, that is colors red, green, blue, yellow, orange. I'm giving here some values to define standard color for the circle around the object. Now if a video path was not supplied, grab the reference to the webcam, which I mentioned before. So here if not argparse.getVideo is false, then camera equals to cv2 video capture. This will capture the webcam, else grab a reference to the video file, that is camera equals to cv2 video capture argparse video. And after this keep looping, that is while true. Grab the current frame, that is grabbed frame camera.read. And finally if we are viewing a video and we did not grab a frame, then we have reached the end of the video. So if arg.getVideo and not grabbed, break. So this code is not in use because I'm not accessing anything from the IP. Now resize the frame and blur it. Frame mutils.resize frame width is equal to 600 and convert it to the HSV color space, that is blurred cv2 Gaussian blur and HSV equals to cv2 cvt color blur color bgr to HSV. Now for each color in dictionary, check object in a frame, that is for key value in upper dot items. Now construct a mask for the color from dictionary 1 and then perform a series of dilations and erosions to remove any small blobs left in the mask. So this whole code, that is kernel equals to mask, this will do that thing. Now find the contours in the mask and initialize the current XY center of the object. That is, counters equals to cv2.findCounters to center equals to none. Now only proceed if at least one counter was found. That is, length of counter should be greater than 0. That is, if length counter greater than 0. Now next, find the largest counters in the mask, then use it to compute the minimum enclosing circle and centroid. That is, c is equal to max. To center, this whole code will find the largest counter in the mask, then use it to compute the minimum enclosing circle and centroid. After that, we have to put condition on the radius, that is, only proceed if the radius meets minimum size requirement. Here I am writing if radius is greater than 0.5, you can change it according to your object size. Now finally draw the circle and centroid on the frame, then update the list of tracked points. That is cv2.circle frame cv2.putText frame key. So this will draw the circle and centroid on the frame, then update the list of tracked points. Now show the frame to our screen. That is cv2.imShow frame. If the Q key is pressed, stop the loop. So you can stop the webcam by pressing the Q. So for that, key equals to cv2, wait key 1. If key equals to Q, then break. Finally, camera.release cv2.destroy all windows. This will clean up the camera and close any open windows. So this is the code. There is no other way for me to explain this code, so this is how it is. You have to understand it code by code and use it wherever you can. Now let's see the output again. Let's run my script. You can see that my window is opened and my web camera is operating. You can see different object with different color has been identified. It will track easily wherever you take the object, and it also displays the color. So this is how color tracking is done. So that's it in this video on multiple color object detection and tracking. Thank you for watching this video.